In this example, I'm going to do a transistor switch. So I'm going to draw my circuit. It's going to be my base. This is ground. So this V is going to equal 9 volts. This resistor RC is equal to 400 ohms. And this resistor RB is 1K. The other thing is I'm going to say that this source is going to be 3 volts. So what I need to do is find all of the V's. So I'm going to find VB, VC, VCE, VE, and IB, IC, and IE. Okay, so what I want to do first is I want to figure out what's going on in cutoff. When my transistor is off, that means that I have to, let's see, I can draw this is my 3 volts. This is my base, so I'm going to call this my base. I've got a diode, that's my ground, and that's my emitter. So remember, this is ground. And what happens when this is off, I'm actually going to erase this, and I just have this. This is my, and during cutoff, this is what's going on. And for my base to my emitter, and in this case, I have my RC, then this is C, this is E, and this is ground. Okay, so that's what's going on. If the base to emitter is not on, then that means my collector to emitter is not on, and so no current flows in any of those circuits. So, but when I'm in saturation, then I have 3 volts. I'll call this my RB. This is my B. There's my diode between the base and the emitter. That's my ground. And this is 1K, it's RB. And now on the collector side, the collector to emitter, so this is base to emitter side, this is what turns on my transistor, and now on my collector side, I have 9 volts, this is my RC, 400 ohms, and RC, this is my C, this is my E, and that's my ground. Okay, so in saturation, I can see that my the voltage at E, this spot right here, that voltage, it's connected to ground. So my VE has to equal 0 because it's at that point it's connected to ground. And the same thing here at this point right here, my VC also has to equal 0. So just look to see on your saturation what your values are. If we say that there's actually, so sometimes we have 2 models where we say that the base to the emitter, that junction loses 0.6 volts. And then sometimes we say that VCE, when it's on, is equal to 0.3 volts. And so that means the voltage between here to here, here to here, is 0.3 volts. And so, so that would mean if this is 0.3 volts here, so imagine there's like a little resistor, then VE is going to be still 0, but VC would be, VC is equal to 0.3 volts, right? So if there's no voltage used, if they don't specify a voltage used, you can assume it's 0. If they do, then you want to say, okay, the voltage between here is 0.3 volts, and that means I'm 0, 0, 0, 0 on E, and then I use up 0.3 volts between C and E, so I must have 0.3 volts at C in order to be able to drop it as current goes through. So this would have to be 0.3 volts. So either way, it's going to be either at C, it's either going to be 0 or it's going to be 0.3 volts. So far then we know that, and let's assume in this case that it's true, that we'll say that this is true. So we will use, we're going to erase this there. So far then we have VE is equal to 0, VC is equal to 0.3 volts, VB, if I look at VB here, so VB right here, or VE right here, this is 0, and then this uses up 0.7 volts. So I have a voltage drop between E and B of 0.7. So that means that, so this VE is equal to 0. That matches what's happening on the C to E circuit. And then this VB has to be 0.6 volts. So VB is equal to 0.6 volts. And how do I know that? Well, I know that I have to be able to have 0.7 volts at B in order to be able to use it from B to E. And then I know that E is at 0 because it's connected to ground. It's directly connected to it. So that's why my VB has to be 0.6 volts. Okay, so next we will find what our IB is. So IB we know is the 3 volts minus 0.6 volts. So that's taking my voltage here, subtracting what the diode uses, 0.6, and then I'm going to divide it by RB. So I'm going to get, let's see, I need to do that calculation. So that's going to be, let's see, 3 minus 0.6 equals 2.4, and then divide that by 1,000. 4 divided by 1,000, 0.0024. So I get 0.0024 amps, or IB is equal to 2.4 milliamps. So you have to look and see what is asked for there. Okay, well, what about IC? So IC is equal to, looking back at my circuit, so I'm losing 0.3 volts. So I'm going to do 9 minus the 0.3 volts that are used between C and E, and then divide that by 400. So I'm going to have 9 volts minus 0.3 volts divided by 400. So 9, 8.7 divided by 400. And I get, this is 0.022 amps. And so IC is equal to 22 milliamps. Okay, and then what about IE? So IE is equal to the sum of IB plus IC. So IE, adding them together, that's 22 milliamps plus 2.4 milliamps, and I get 24.4 milliamps. So that gives me all of them. So then I think I forgot, VCE is equal to 0.3 volts.